I'm seeing.
Okay. Yeah, hi. Good evening. So in our last session, we've gone through, like some of the network basics. And those are, like what is a host and what is network, what is networking, and what is MAC address, and like and in detail about MAC address and how to find the MAC address, and we gone through like what is an IP address, and how many bits it is, and the IP address classification, like A, B, C, D, E, and the range, class ranges, and we gone through small example of private IP and public IPs. Okay, so far any questions for you, Jivan?
No, I'm clear with that.
Okay, cool. Let's proceed further. Okay, so private IPs, and see, apart from we have ABC classes, right? A, B, C, D, E. So among all the classes, we are using mainly ABC classes only. No, so here from ABC they have taken few of the IPs are related to private IPs. Apart from these IPs, okay, any IP is a public IP address. Apart from private IPs, everything whatever it is available, those are public IPs, we can call it as. Okay, so here the public IP is directly accessible over the internet. Internet is nothing but like in public network, we can say. Okay, private IPs, it only private IPs, it's only used inside the network. Inside, but public IPs, it's outside network, that is public network, that is internet. Okay, so these public IPs will be provided by our ISP. ISP stands for Internet Service Provider. So it means like from like from whom we are taking the internet connectivity. Suppose I'm having a Wi-Fi connection which is from Act FiberNet. Okay, so here if I want to access internet, okay, so let me tell you an example. This is my home. Okay, so I have taken a Wi-Fi router, and and internet is providing by Act FiberNet. Okay, so here what happened? So whenever a Wi-Fi router is turned on and it's having the internet connectivity, it is assigning IP addresses to my mobile, my computer, my tab, like whatever it is there. Okay, so it is assigning private IP addresses inside the home. Okay, and if these guys, like from any of the host, okay, is mobile or computer or tablet, when I want to access internet, google.com I want to access. Okay, so what happened? These private IP addresses can't be accessible over the internet. Okay, so these IPs need to change with the public IP, public IP address, the public IP address. Okay, so this public IP address, I know, like it will be taken care by Act FiberNet itself. Okay, because they are owning they have taken, like they have purchased those public IPs from IANA. Okay, so that is about like public IPs. So here like a public, here our private IPs are hidden while accessing the internet. So while accessing the internet, our private IP address will be hidden with the public IPs. Okay, so these public IPs will be provided by the internet service providers or IANA. Okay,
Okay.
yeah. So this is an example I was mentioning. So we have the Wi-Fi router, and this Wi-Fi router is providing IP addresses either through wire or wireless connectivity. It's providing some IP addresses to us. Okay, so if you observe here, all the private IP addresses, right? This is from class C, na? From
Yeah.
class A we have one to like 126. Class B
128
128
to
to 191,
1,
and class C 192 to
223.
223 is a class C, right? So here we have a private IP address range from class C, that is 192.168.0.0 to 192.168.255.255.
255.
So these are the range we have the private IP address from class C, class C IP addresses. So here if you observe, all these are private IP address range only, na?
Mm.
So if these guys want to access internet, Okay, so these private IP addresses can't be routable in the internet. Okay, so that's why our whoever ISP means internet service provider. Okay, so here my internet service provider is Act FiberNet. Okay, so here Act FiberNet is providing a public IP address to me. Okay, while accessing the internet. Okay, that's about like the differences between private IP and public IPs. So here also like a kind of same example, but in different fashion. That's it. So this is also a private IP, right? Like 192.168, 0.02, 255.255. No, so this is also private IPs. Okay, so it means when you connect it to a Wi-Fi network or any internet, okay, any network, so you will get a private IP addresses from that range. From A, B, C we have, right? From A class A, what we have? 10.0.0.02, 10.255.255.255. Okay. From class B, what we have? 172.16.0.02, 172.31.255.255. From class C, what we have? 192.168.0.02, 192, 168, 255 to 255. Okay, so these are the private IP address ranges what we have. But most of the cases, you can see only these IP addresses will be assigned, you know, in the general scenarios. Okay,
Okay.
so let's have some small differences between private IP and public IPs. Okay, so in private IP it can be used within the LAN network. Okay, so with like as it is shown here. Okay, so within the LAN or within the network only private IP address can be used, and public IPs it is used in the internet or public cloud. Okay, and these private IP addresses, why we are not like these private IP addresses not routable over the internet, because it is not recognized in the internet. That's why this private IPs can't be routable in the internet. Okay, so when you're trying to access a google.com, our private IP is hidden by the public IP address, right? Why? Because these private IPs are like not recognized over the internet. That's why. And public IPs they'll be able to recognize over the internet, I can say. Okay, and here what we need to remember here, whatever the private IPs is there inside the network. Okay, this will be assigned by the network administrator or LAN administrator. Okay, so in the older days, like a LAN administrator and network administrator, they will log into our computers and they'll provide some IP addresses to us. But now in the growing world, we have you know DHCP concept coming into the picture. DHCP, dynamic host controlling protocol. Okay, suppose if you connect it to a Wi-Fi router. Okay, and as soon as you connect it to Wi-Fi router, you are getting some IP address, right? So this process is called DHCP. It means whenever a user or whenever a mobile device or any device which can send or receive the information which is connected to internet or any Wi-Fi router means it will be able to get the IP address. Okay, that process is like called a DHCP process, dynamic host controlling protocol. Okay, and the backend, like why how our device is getting IP addresses, there will be performed in a four steps process is here, that is called DORA process, we can say. I'll tell you, like, discover, offer, request, and acknowledgement. Okay, we'll discuss about that later on. But for now, these private IP addresses, either it will be assigned by the network administrator or by DHCP. That's what I want you to understand here. Okay. And but in case of public IP addresses, okay, so these public IP addresses are like it is be provided by like IANA or service provider. Okay, so and this is chargeable. Okay, this by we have to pay the money to get the public IP addresses, but in case of private IP, it's a free of cost. Okay, and in case of like if you can say in the organization perspective, okay, this private IP it should be unique one. There won't be any conflicts. Okay, and this public IP addresses it is unique with the global itself, because we have the IP addresses ranging from 1.0.0.02 to 255.255.255, right? So among them only we have private IP addresses, okay, which are available to configure or provide in the internal networks. Okay, but these public IP addresses, it won't be I mean what I can say, um, Hmm. This public address we won't configure to every machine which is available in the inside organization. Okay, it will be assigned only at the gateway point where external connectivity is there or where internet connectivity is there. Okay, so we can say it's unique over the global networks. Globally means it's a worldwide. Okay, this public IP addresses it won't be what I can say duplicate. Okay, and it's a to purchase public IP addresses we need to pay some money. Okay, so this is about like a public IP address and the private IP addresses, and like these are the ranges of private IP and public IPs. Okay, is it clear or any doubt, Jeevan?
Yeah, clear.
Okay, 1 second. Why it is happening? Just a minute. Yeah, sorry. So we know these are the range of public IP addresses and private IP addresses, right? So from class A, class B, we have a 10 series and 172, 172.16 and 192, 168 series. And apart from these IPs, whatever we have, those are the public IP ranges. And this will be maintained by IANA Institute. So let's go further. Okay, so let's see about network types. Okay, so if you remember in the demo class we discussed about like what is LAN, what is MAN, and what is WAN, right? So LAN is nothing but local area network. So it's like limited to a single area. Okay, so single area we can say, or inside organization. Okay, so single building we can say is a LAN. Okay, you got the point. Like local means it's local to itself. That's it. So we have an organization. Okay, like let me tell you in a simple way. Okay, so we have some XYZ company. XYZ company is there and it's having some building. Okay, so this building totally like to internal itself. Okay, so this is called a LAN network. That is local area network. Okay, and when it comes to MAN, okay, so this XYZ company it is located in like a metropolitan city, something like that. Okay, so it is in one location in one location in the city, and they have one more building in the other location in the city. XYZ branch A, XYZ branch B. Let's consider like that. Okay, both are in the same city. Same city, we can say. So like those kind of network is called like MAN, metropolitan area network. And next one is WAN. Okay, so we have XYZ company. Okay, it's in Bangalore. Consider it's in Bangalore. Okay, so they have the same kind of same company in Chennai also. Consider like that. Okay, XYZ Chennai. Okay, so here also they're there. Okay, so now the connectivity between these things, okay, between the different cities is called like WAN. That is wider area network. Okay, LAN means it's local to a building. We can say that's a LAN, and MAN means it's a two kind of two networks which are in the same city. And WAN means it's a wider area network which is like between the cities. We can say this is about LAN, MAN, and WAN. Is it clear?
Yeah, okay.
Yeah. So we have like network topology. Topology means how we are connecting. Topology is nothing but how we are connecting the network devices. Okay. So network topology means how we are connecting the network devices. Okay. So we have like many ways. Okay. So first one is P2P means it's a point to point topology. So it's nothing but like there is there are four network devices. Okay, so each network device is connected to 2 points. Okay, it's connected to one point and it is connected to one point. Okay, so we can say one device can connect to only two devices in case of point-to-point topology. Okay, that's about point to P2P topology. And in case of bus topology, okay, a serial line will be there. Okay, there is a line. Okay, and to this line, all the network devices will be connected like this. Okay, this is what like point-to-point topology and bus topology. Bus topology is nothing but to a wire or to a network cable. All the devices are connected. Okay, so that kind of topology is called bus topology. Okay, and next one is ring topology. Okay, so the name itself it is telling it's a kind of ring. Okay, so what how the ring it would be like consider that this is the ring. This is the ring, right? Just consider like kind of all the areas it is closed. Okay, so this is the ring topology. And star means a device will be there, and like many devices are connected to this device. Okay, it's look like star. So this is about like star topology. So here the devices are connecting like in the it depends on the shape how we are connecting. So with respect to the name of the shape, they are considered like that. So ring topology or star topology. Okay, mesh means like all the things like every device will be connected to each other. Okay, so we have like uh three devices. Okay, so these three devices are connected to each other. Okay, we have one more device coming to the picture. Okay, this is connected to this is connected to this is connected to this. Okay, so like all the devices are connecting with each other, right? So that is about mesh topology. Okay, and next one is tree topology. So here we have one device. Okay, and we are connected to two devices. And again, it's a I mean forming of a tree like this. So see, these are the just simple terms. What we need to aware how we can connect the network devices. Okay, that's all. Nothing much to focus on. So depends on the shape how we are connecting the devices. That is called the topology. And if you connect it in the tree shape, it's a tree topology. Okay. And hybrid means combination of the all the things. Okay, combination of either star topology or bus topology. All the topologies is called hybrid topology. Okay. So any questions regarding network topologies?
May I know which type of topologies are using in the organizations?
See, it all depends. Okay, like how they want to access. See, mostly it will be like ring topology. We can star topology. I can say. So here what happened, in case of organizations, okay, so we'll be having a device, okay, so this device will be there, and to this device, many devices will be connected to each other. So we can say it's a star topology mainly.
Okay.
Okay, so like why star topology? I'll explain you. Okay, so in the coming classes now itself will explain. Okay, so for now you are clear, right? Like what's the topology and what the topology name it's defining how we are connecting to that.
Network devices.
Yeah, clear. Let's go
Yeah,
further.
okay.
So like I mean how we are connecting. So if we want to connect two devices, okay, source and destination, like computer A and computer B is there. How we are connecting these devices with each other? We have two ways, right? Either we can connect with the cable or a wireless connectivity. Okay, so let's see what is wire. Okay, so this wire connectivity is called these are cables. Okay, so here we have computer A and computer B is computer B is there, and if you want to connect these two computers with each other, okay, we need to have a cable. Okay, so through the cable the data will be transferred between computer A and computer B. Okay,
Yeah, okay.
so it's not only two devices. Okay, if you have a number of devices, we need to connect with the cables. Okay, and like if the number of devices increases, okay, it will be difficult. That's why we have some devices coming into the picture. I will discuss about them. Okay, so we have different types of cables available in the market, that is LAN cables. So and we have optical fiber cables. Okay, so in case of I mean LAN cables, okay, copper wire will be used. Copper wire. Okay, so here so in case of this one, okay, so in case of copper cable, copper wire, okay, here the traffic will go as a electrical signal. Okay, so suppose you have one computer, okay, and you have another computer. Okay, if you are sending any information to one computer to another computer, okay, which is connected with the LAN cable. So what happening? Whatever the data you are sending, it won't send the data exactly. Okay, so it will suppose you are sending a hello message. Okay, this hello message, it won't send hello as in the cable. Okay, it converts into the electrical signal, and it when it reaches the destination, again this signal will be converted to a normal message what you have sent, like hello. Okay, so here if you are using like LAN cable, the signal will go as a electrical signal. Okay, but in case of optical fiber cables, okay, if you connect optical fiber cable between source and destination, like between the computers, we can say it is light signal. Okay, so here the drawback of we can say yeah, for the electric like LAN cables, the redundancy will be more. Redundancy means withstand capability is more because it's a copper wire, and we can though you can fold also, there don't be any issues. Okay, so but in case of optical fiber cables, okay, if any a bends or like if any damage did happen, it won't be able to transfer the data. Okay, so we can say copper cables are having more standability or redundancy, we can say. Okay, but in case of copper optical fiber cables, it's having less redundancy, and it's a more we can say we have to handle with care. Like more care is required in case of optical fiber cables, but in case of LAN cables, there is no need of such care if you are doing for optical fiber cables. So mostly like in our organizations, okay, like LAN cables only are we are using. Okay, and if you can observe if you are purchasing any Wi-Fi internet connectivity to your home. Okay, so they'll ask, okay, whether you want copper connectivity or fiber connectivity. Okay, so here see, it depends on the area how they are serving. Okay, so to suppose in my area itself, okay, first I thought go for Airtel or Geo. Okay, they told, sir, we are having only copper connectivity to your area. Okay, so it means that they will connect, they will provide the internet connectivity over the copper cable. So here if you compare with 1 second. So if you compare with electrical signal and light signal, electrical signal speed is less if you compare with light signal. Okay, so what happened? So in case of electrical signal, the fast is less, internet speed is less. Okay, but optical fiber cables, it's a light signal, speed is more, high speed we can say. Okay, you got the point what
Okay.
I'm trying to say? So they told, okay, the copper connectivity is there, but less speed. But we have optical fiber connectivity with respect to another broadband connectivity, that is act fiber net. Okay, so act fiber net, they are providing fiber services to my home in my area, so they are providing high speed connectivity for me. So I have chosen fiber connectivity because I need high speed. Okay, but if I want to with low speed, I can go with LAN cable connectivity, that is copper connectivity. So it depends on the cable what we are using. Okay, it depends on the network fast also. Okay, so is it clear about the LAN cables and optical fiber cables?
Yeah, clear.
Yeah. So we have like two computers again. Okay. So what if they connected to like more distance is there? Okay. If they connected with the less distance, that is fine. Okay. But if computer A and computer B, okay, they connected with a long distance. Okay. So here if that signals are passing through the medium, there is a possibility of signal strength will be reduced here. Okay. Signal strength will be reduced. Okay, so whatever we are sending the data from computer A, ABC, that quality it won't be available in the computer B when it receiving. Okay, so that's why, like, we have one device coming into the picture, that is a repeater. Okay, so repeater a device, what it does, repeater is, whenever it is receiving the signal. Okay, so whenever computer A is sending to computer B, and when they're connected with a long distance. Okay, so we can keep the repeater in between, and it regenerates the signal. It regenerate the signal to computer B. So what happens? Signal strength, it will be same. For sending and receiving signal strength, it will be the same if you're using the repeater network device. Okay, so this is one of the network device, repeater. So repeater is so if anyone will ask you what is repeater, okay, so you can simply say repeater is a network device which can regenerate the signals. Okay,
Okay.
so clear.
Yeah.
Let's go further. So how so if you want to represent, how symbolic representation. Okay, this is how we can represent. I can say repeater. Okay, so if you are, what I can say, symbolic representation is nothing but, suppose you are representing an user. How we can represent this? Is how we can represent, right? If you want to explain anything, this is a user. Okay, in a similar fashion, if you want to represent a repeater, this is how we can represent. And so this is how, the actual device. Okay, so it having two ports. One is income ingress port and egress port. So source side is connected to these devices, and destination this is connected. Okay, and if you can see, like in the older days, we have disconnectivity, right? If you remember, disconnectivity.
Yeah.
So if you observe, like in between some kind of devices, they will arrange, to connect the cables, right? If you remember. So this is the repeaters. Okay, so what they do, they will regenerate the signals, and they can
Okay.
connect the, like input and output signals also. We can say in a simple way. Okay, so this is about repeater. Now in the real time, this is how, like we can use the repeaters. Okay, but nowadays repeaters are no one are using. Okay, but in the old days, we have the repeaters available.
Okay.
But we need to but we need to remember what is repeater and what is the functionality of it. Okay, clear? What is repeater?
Yeah. Yes.
Okay, let's go further. Suppose, like we have like two computers. Okay, so we connected with each other with the cable. Okay, whatever it is showing now, consider that, it's a cable. Okay, so what if we having one more computer? Okay, we are connecting with each other, right? They want to communicate with each other. The aim of this network is they want to communicate with each other. Okay, so they connected with the cable. One more computer is there. Okay, again, what we are doing, we have to connect all the, to all the computers, right? Like this. Okay, and again we have one more computer. Okay, and it is connected to all the other computers which are, available. So if you can say, like if the number of computer is adding, okay, so the number of cables also is increasing, right? If you can see here, able to, you are with me. See, if number of devices is adding, okay, so we need to have more cables to connect with each other, right? So if you can say, like we are using n number of cables to make communication with everything. Okay,
Okay.
so if you can looks like, like if you add one more device, okay, so you need to connect to all the devices, right? All the devices. Okay, so it is too hard to, like to maintain, too hard to maintain, and like it will be, very complexity also, if you can observe here. Okay, so that's why we have one device coming into the picture, that is called hub. Okay, so we have these devices. So what we are doing now here, we are we are placing a new, like, one network device in the middle. Okay, and we are connecting all our computers to it. So what happened now, if you have one more computer is adding, okay, what you can do, you just connect it to hub. No need of connecting to all the computers. Okay, got it?
Yeah.
So we can say hub is a network device which can connect all the computers which are like which need to communicate with each other. Okay, hub is a network device which can connect all the computers which are which are needed to communicate with each other. Okay, suppose let's let's keep some names to like all the computers, computer A, B, C, D, E, all these things. Okay, suppose so here computer A is sending some information. Okay, so suppose to what it is sending. So computer A wants to send information to computer E only. Okay, so these devices want to communicate with each other. Okay, he's sending a hello message to E. Okay, but what hub is doing here, if you can see. Okay, so hub, it is sending that information to all the computers which are connected to it. Okay, so our intention is just to send hello message to computer E only. But what hub is doing, it is sending to all the computers which are connected to it. Okay, that's the functionality of hub actually. Okay, so we can say hub is a network device which can multiple network devices are connected with each other, and if any device sends a communication to other device, the hub will transfer the device to all the other devices which are connected to it. This is what hub it is. Clear? Any questions?
Yeah, clear.
Okay. Suppose here like G is sending some information. Okay. So suppose it want to send some information to only H in general. Okay. But what it is doing here, it is sending the hub is, so here from G, hello message is going to reach hub. Okay. And this hello message is sending to all the computers, right?
Yeah.
So that is the drawback. But we need only for H, but it is sending to all everyone, right? So this is the drawback of hub. Okay, so that's why we have one more device coming into the picture, that is called switch. Okay, we'll discuss about switch also. But I want you to understand what is the hub and what is functionality. Okay, hub is used to connect like devices in the LAN. Okay, that is local area network. Okay, I think our class will be end in 5 minutes. Let's complete hub. Okay, so this is the symbolic representation of hub. This is the actual device. Okay, so if you can observe here, we can in general. Okay, if anyone will ask you how to represent hub, this is how we can say. Okay, and this is how like the actual device looks like in the organizations if you want to configure anything. Okay, and so as I mentioned, hub will be consist of many ports. So each port a device will be connected. Okay, this is about hub, and this is how we can use in the real time scenarios. Okay. And we have a number of network devices. We'll go one by one. For now, cables, in this class we discussed about what is the differences between private IP and public IP addresses, and we gone through what is a cable, and different types of cables we have available, and we know what is repeater, and what the functionality of the repeater, and why we need hub because it's too cumbersome, right? If you want to communicate, add more devices. Okay, in organization we'll be having n number of devices now. So for here 8 devices itself we are using this many number of cables. Okay, so in organization we'll be having hundreds of computers, right? Hello.
Yeah, Harshan.
Yeah, in organization we'll be having hundreds of computers. If you want to connect with each other, it will be very hard if you're using single cables. That's why we have network devices coming into the picture. So by using hub, we can connect all the devices, and like we know what is the functionality of hub. It will transfer the data to all the other ports which are connected to it, except the port from where it is received. Okay, that is about
Okay.
hub, and yeah, that's all for today. We'll have discussion in the coming classes.
Okay.
1 second.